In our last video, Mitchell, you showed us how to pick the right Cloud Run billing model and how to estimate costs for a new cloud app that uses Cloud Run.
Yeah, that was fun.
I enjoyed it too. What about optimizing Cloud Run service that's already been deployed?
Let me show you how to do it.
Welcome to the show, Mitchell. What do you do here at Google?
I'm an engineering manager on Cloud Run. My team focuses on the cost and performance of Cloud Run serving infrastructure.
It sounds like you are just the right person to ask about cost optimization in Cloud Run. So I've used Cloud Run a lot over the years, but to be honest, I haven't really dug into the billing. Let's say I'm running an application that uses Cloud Run. How can I save on my cloud bill?
So here's how I think about it. First, you want to prevent billing surprises. And second, you want to optimize the cost of your running service.
Okay, I've heard from many developers who are concerned about the first item on your list, billing surprises.
That makes sense. Any system has expected traffic where everything will work as normal and unexpected traffic beyond that.
Okay.
So let's say your system runs on traditional servers. You might have a web server and a database server. If you get more traffic than either of those servers can handle, some users will be turned away.
Got it. But serverless is a different story, right?
Yes. With serverless computing, like Cloud Run, you can choose what should happen when traffic increases. You can turn away users, like a traditional server-based system, or you can scale up and handle the extra traffic.
In what situations would I want to scale up?
Well, let's say you're running an online store. Then you don't want to turn customers away.
Right, I won't say no to more revenue. But what if I don't want my system to scale up and pay for that scaling?
Well, that's easy. You can set max instances to a number like 2. That means that Cloud Run will prevent your service from scaling up beyond 2 instances. If you get more traffic than those 2 instances can handle, users will be turned away.
That sounds useful. Is there some way of allowing surges in traffic from real users, but not from attackers?
Yes, there is, but it requires a little more work. You can require requests to your Cloud Run service to be authenticated. You can use identity-aware proxy, identity platform, or Firebase authentication for that.
But what about if my Cloud Run service supports anonymous users who don't log in?
Then you can use Firebase App Check. Another option is to use Cloud Armor and a load balancer. Cloud Armor is a web application firewall, so you can set rules for what kind of traffic to allow. For example, you can set rate limits so one group of clients can't exhaust your system resources. You can also use Cloud Armor to stop common attacks, like SQL injection or cross-site scripting, or to block bot traffic.
Very good. Now, let's say there's a large increase in traffic and in my bill. I want to know so I can take action.
Yes, and that's where budget alerts come in. You can trigger email or PubSub alerts when Google predicts that your cloud bill will hit a certain dollar amount. Or you can set it to trigger if your cost will be larger than the previous month's bill by a certain percentage.
Good stuff. That will help me sleep better at night and worry less about cost overruns. The second item on your list is how to optimize the cost for running service. So to be honest, the Cloud Run cost in my web apps is less than 10% of the total bill, so I haven't really worried about it.
Well, that's true of your application and many others, but everybody's application is different. We should still talk about how to optimize an existing Cloud Run service.
Fair enough. How do I do that?
So in the Cloud Console, go to Cloud Hub and Optimization.
And this is a new page, right?
Yeah, it was launched recently. You can see a lot of this information in the billing section of the console too, but this page is built to help you optimize your application. Here, you can see the trend in total cost over time for all products in your project, not just Cloud Run. The total is broken down in the cost and utilization section down here.
Got it.
So I'll click the link View Details in Cost Explorer. And here's a more detailed breakdown. Cloud Run services cost this customer $370 in the last 30 days. And Cloud Run jobs cost this customer $157. Down here, we see that the Cloud Run cost has increased by 3%, while the cloud logging cost has dropped by 1%. If there are big jumps in these numbers, you should investigate. And over here, the cost trends are broken down further. It looks like the service called API drives most of the Cloud Run cost.
I see.
I can switch over to this vCPU utilization view. This table shows how much virtual CPU different Cloud Run services are using. The Discord bot service is only using 2% of its allocated CPU. This customer may be able to save some money by allocating fewer CPUs to it.
Got it. And the customer is paying for memory too, right?
Yes, they are. Let's check the memory utilization report. It looks like this animated WebP service is only using 0.5% of the memory allocated to it. The customer could probably save some money by allocating less memory to it.
Nice. But you said that the service called API is driving most of the Cloud Run bill here?
Yes, it is. Let me click it to get more details about that service in particular.
That's a lot of additional data.
Yes, there is. I'll scroll down to the charts for CPU and memory utilization. The instances don't use a lot of CPU or memory, so we should consider raising the concurrency limit. That way, each instance will take on more requests, and you'll need fewer of them, and you will pay less. By default, this is set to 80, but some services may be able to handle even more than that.
But if I raise the concurrency limit too high, won't my system grind it to a halt?
If your workload is CPU bound, it's safe to have a fairly high concurrency because Cloud Run will start new instances if your CPU is working too hard. Once you've tuned concurrency, you should check that your Cloud Run instances have the right amount of memory. Let's check the memory utilization over on the right. If your instances use very little memory, consider lowering the memory allocated to each instance. That will save you money.
Got it. I guess I want high CPU and high memory utilization.
That's right. Finally, aside from tuning, there's one more way to save money: compute flexible committed use discounts. If you have predictable traffic, you can enter into a contract with Google that you will use a certain amount of processing and you get it at a lower price. By the time you watch this video, there may be automated recommendations in the Cloud Console for this.
So you'd commit to using a certain dollar amount's worth of Cloud Run per hour?
Actually, you commit to spend a certain amount per hour per region across Cloud Run, Compute Engine, or Kubernetes Engine. So if you use less of one, you can use more of another.
All right. That was a lot of useful information. Could you recap it for us, Mitchell?
Sure. First, prevent billing surprises with max instances, authentication, Firebase App Check, or Cloud Armor. Also create budget alerts. Second, use the optimization report to find out what drives cost and which services have low utilization. Allocate fewer resources to them. Also, don't be afraid to set your concurrency limit high. And consider using committed use discounts.
Very useful. I knew some of this, but far from all. Thank you for sharing this with us, Mitchell.
Thanks for having me.
And thank you, everyone, for watching. If you have any questions for Mitchell or me, please let us know in the comments. Also, do let me know what you thought of today's episode. I read every single comment. Until next time.